All right, so we're going to talk about here how to make a unit circle quite easily so that you could recreate this yourself at any point in time if you should lose your unit circle or you need to use it on a test. Okay, so I've already created all of these angles which represent your 30, 60, 45, and all your quadrantal angles. But what we have to remember is that the unit circle is going to be most helpful when we're dealing with radians. So all of our angles that we're going to be putting around this interior circle are going to be in radians as opposed to degrees. So let's fill out this first quadrant here with the pi over 6, pi over 4, pi over 3, and pi over 2. So this is basically the 30, 45, and 60 degree angles. We're going to go ahead and figure out the rest of the quadrantal angles, which over here would be 0 radians, or if you go all the way around, it's going to be 2 pi radians. This side over here is going to be pi, down here should be 3 pi over 2. Okay, so now that we have those taken care of, what we're going to do is, if you notice the green lines, those all represent the 45 degree angle, reference angle, or angle. But in radians, that's pi over 4. So we can count by pi over 4 radians as we go around the circle, remembering to include the quadrantal angles. So if this is 1 pi over 4, this is 2 pi over 4 having been reduced. That makes this 3 pi over 4. This is 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, and then 7 pi over 4, and of course back up here at 8 pi over 4, which is 2 pi. So that takes care of the green lines. The red and the blue lines, those are basically multiples of 30. And in radians, that would be multiples of pi over 6. So we can count by pi over 6. This is going to be 1 pi over 6, 2 pi over 6, 3 pi over 6. Notice that we skipped over the green. We don't need to count it because that is not a multiple of pi over 6. So we have 3 pi over 6, so that makes this 4 pi over 6, which reduces down to 2 pi over 3. So this is 5 pi over 6, 6 pi over 6, 7 pi over 6. This is 8 pi over 6, which is 4 pi over 3, 9 pi over 6, 10 pi over 6, and 11 pi over 6, leaving us with 12 pi over 6, which is the 2 pi. So now we have all the radians going around. And if you notice with the colors, with these lines, every line that has the same color has the same denominator. So all the green lines have the denominator of 4, all the blue lines have a denominator of 6, all the red lines have a denominator of 3. It's pretty interesting, right? Well, all of these lines that have the same color, these are all lines that have the same reference angle as the angle that's in the first quadrant. So this blue line here has a reference angle of pi over 6. So does this one and that one. Okay? So what we're about to do right now is come up with coordinates for these points. So there's like a point right here, okay? Because technically we are on the Cartesian coordinate plane. We have this x-axis and we have this y-axis. So if we were trying to figure out the coordinates of this point, we'd have to go over a certain distance in the x direction and we'd have to go up a certain distance in the y direction. So I can drop this down like this, making a nice right triangle. And this angle right here is technically the angle that I have written right here as pi over 6, which is really 30 degrees. And in a 30, 60, 90 triangle, remember the hypotenuse, you take the hypotenuse, which since this is a unit circle is going to be 1 unit, the side opposite 30 is going to be half of that, so 1/2. Okay, and then the side opposite 60 is you take this side, whatever this length is, and multiply by √3. So this is going to be I should have typed this in, √3 over 2. Okay, so now that we have that established, to figure out the coordinates of this point, we're going to be going over √3 over 2, and we're going to go up 1/2. So the coordinates of this point are √3 over 2, comma 1/2. Okay, so we can do the same process. I'm not going to go through it, but we can do the same process with the green line and the red line. The green line gives us a 45, 45, 90 triangle, And if this is 1 unit, then each of these sides, which should be the same, are going to be root 2 over 2. So that means the coordinates here are going to be root 2 over 2, comma, root 2 over 2. For this line at 60 degrees, or pi over 3 radians, when we drop our line down here, this angle is the 60 degrees, and the little angle up here is 30. So that means this side is going to be the 1/2, and this side is going to be the root 3 over 2. So pretty much these coordinates are the same as those, just x and y have been switched. All right, now let's go back and take care of our quadrantal angles. The point right here, this point which is on the x-axis, remember the radius of this inside circle is 1 unit, so we're going over 1 and up 0. Likewise, the coordinates of this point right here, we're going to go over 0 and up 1. This one, the point right here, we're going to go over -1 and up 0. And the coordinates down here, we're going to go over 0 and down -1. So those should be pretty easy points. Now, filling in the rest of these coordinates going around the circle is actually really simple because, remember, these are all the same as the ones over here. Like, this line has the reference angle of pi over 6. So the coordinates are going to be identical to what you have here for the blue line. The only difference is maybe a plus or minus sign. Okay? So you can think of it in two different ways. You can think of it moving in your Cartesian coordinate plane, where you are going in a negative direction and then a positive direction. So your x should be negative and your y should be positive. Or what you can do is recall that this right here is cosine and this is sine. We'll talk about that a little bit more later. So if you use all students take calculus, you know all the sine coordinates should be positive, all the cosine coordinates should be negative. So we can fill all these in. Notice the 1/2 and the root 3 over 2, it's the same as here, only the 1/2 is negative. Same thing for the green line. It's the exact same thing, only the x coordinate is negative. Likewise with the blue, same as over here, only x coordinate negative. So you can imagine if we were down here in this quadrant, both the x and the y coordinates have to be negative. So there you go. And then if we were in this quadrant, your x is going to be positive and your y is going to be negative. Okay? So like I had mentioned before, the reason that this unit circle is so handy is that these coordinates actually represent the cosine and the sine at whatever angle you are looking at. Because remember, and I know I erased this already, but if I were to draw this line down, and this is 1 unit, I'm not going to rewrite those things, but the sine of this angle is opposite over hypotenuse. So if this is 1/2 over 1, well, there is sine. Okay, and then cosine is adjacent over 1, so there's cosine. So what's really nice about this is when you have this tool in front of you, if I asked you, what is the cosine of 5 pi over 3, you just have to find out, there's 5 pi over 3, there's cosine, it's 1/2. You don't need to draw a triangle, you don't need to memorize anything, definitely don't need to use a calculator to figure it out. So this can be a very useful tool. And as well, if you remember all the difficulty you might have had with figuring out or remembering your quadrantal angles, well, there you go. There's the sine of pi, or the cosine of pi over 2 is 0. You can just look at these things and read it off. Okay, so there you have it. There's your unit circle. You can practice that to your heart's content. If you needed to use this on a test, you really only need to create the first quadrant here pretty easily, remembering that anything with the same denominator is going to have that as a reference angle. Figure out what quadrant you're in. These are your sine and cosines, and then just do all students take calculus to figure out your plus or minus signs. All right, there you go. Have fun with your unit circle.